So Formula One is making a bunch of changes this year for 2009. The one I want to talk about is the KERS system, K-E-R-S. KERS stands for Kinetic Energy Recovery System, which was an experimental technology for a long time, used in sort of advanced automobiles that use the power of braking to either spin a flywheel and store energy or to charge a battery that they then, when they go to accelerate later, put the energy back into the drivetrain. So there's two systems going to be used next year in F1. One of them is a mechanical system. This is actually in Italian, so I just turned the audio off so I'll narrate for you. I'm going to zoom in on an engine. That's a motor, with much of the outside moved. This is the drivetrain. This is the rear tires. What they're showing here is the electric. Do I have them backwards? I do. Well, let me see if this one is mechanical. Precious time. Yes, this is the mechanical one. Okay, so ignore the label. This is mechanical. When the brakes are applied, you can see them getting hot there. It spins a flywheel inside of this mechanism here that starts to spin. It's very low friction and it's very high density weight. It spins really, really, really fast. Then the car speeds off down the road. The driver can hit a button on the steering wheel and apply that force back to the drivetrain to spin the rear tires. They can actually get 60 horsepower for about 6 seconds per lap extra. And it also saves their brakes because they're using a lot of the energy of braking. Instead of squeezing the pads, it's being used to turn this flywheel. Make sense? Mm-hmm. So the electrical one, again, ignore the title. Apologize if I got those backwards. Very similar, but instead of using the flywheel, it uses an electric motor, very small but very, very powerful electric motor, and charges a very lightweight but also very powerful battery or supercapacitor. Each team is doing their own thing. They're pretty secret. Nobody's really telling what they're using. But as you can see here, there's electric motor. And when the braking happens, which you'll see in a second here, it starts to charge the battery while they're braking. And then later, in the lap on a straightaway or somewhere where they want to pass someone, they have 6 seconds of power they can put back in to the engine. This is new this year. It's effectively a push-to-pass that is completely using energy that was normally wasted in braking. So pretty damn cool. There's a big safety concern about it, however. This is last week. Watch the mechanic get literally chucked off the car because a supercapacitor discharged into him. So there's a lot of concerns about these right now. You watch this guy, he's just touching the chassis, chucks it. So this is a big deal. There's a lot of news right now about all the safety considerations about the KERS system, and the corner workers are nervous about it. Like if they come in and they go to help the guy and they blow up, or if there's a spark or something. So there's a lot of controversy, but that makes it more exciting. This is for Dick. This is a Formula One Renault team. The Formula One engine is extremely complex and very computer controlled. This is actually the warm-up sequence that they use for Renault.
Harmonics.
Left. That's really the end of the presentation. That was just a kicker for you, Dick. But Formula One cars are about 1,000 pounds. They've got near 1,000 horsepower. They're more than 10 million bucks each. And there's 2 cars per team. There's 10 teams right now, and they're all factory backed. And the rules of Formula One is that factory has to develop a car themselves, build it themselves, develop everything, including the engines. And then race it. They get to race 2 cars, and they have to, this year, the engines have to last 3 races. So it's really amazing.